Hey, welcome back to the lecture. So in this section, we are going to discuss about the clocks of your microcontroller. So the clocks are important component of any microcontroller because without clock, nothing works. So because microcontroller is actually nothing but it's a digital circuitry which is synchronous, right? So synchronous with what? Synchronous with the clock. If there is no clock, then the various digital components of your microcontroller won't synchronize and they won't work at all. So, but what are clocks basically? Clocks are nothing but some square wave signals of certain frequency, isn't it? And for your application, selecting a right kind of clock will be very important, because if your application is low power application, that means you are targeting a low power domain, then you may have to be careful with the frequency of clock which you are using to run your application, because there is a relationship between power consumption and the frequency of the clock, which I'm not going to touch. So there is actually one formula which talks about these relationships. So you can explore the relation. But in this section, what exactly I want you to know is clocking system of the whole microcontroller. Now let's get started. So now for this section, I'll be using my microcontroller, that is STM32F407, and believe me, the same thing applies to most of the microcontrollers of different vendors. There may be slight difference, but points equally they hold good to other microcontrollers also. So I just opened the reference manual of my microcontroller STM32F407, and I am in the section RCC, so that is for reset and clock control, and in that there is a section called clock. So I just opened that. So later you can explore this section, no problem. And here it says that 3 different clock sources can be used to drive the system clock. So now I'll come to the system clock later, not to worry about that. So what basically they are saying is, for this microcontroller, or you can consider any microcontroller, there are something called clock sources. So microcontroller needs clock, and that clock will come from clock sources, and these are the 3 main clock sources for the microcontroller. So now what are the sources? The first one is crystal oscillator, and second one, the second source may be the RC oscillator, and the third one may be the PLL, which stands for phase locked loop. So the crystal oscillator is nothing but an external component which you have to connect for the microcontroller externally in order to supply clock. And if you don't want to use crystal oscillator, for different design considerations, you can drop the idea of using crystal oscillator. Then you can think about using RC oscillator. So the RC oscillator in all modern microcontrollers come inside the microcontroller itself. So that means you need not to connect any clock sources externally to the microcontroller, because this RC is already inside the microcontroller. So you can just activate that and you can use that as the clock source. And there is another clock source that is called PLL, and PLL is also implemented inside the microcontroller, so which generates higher frequency clock by taking lower frequency clock as an input. So now for this lecture and for the next lecture, let's not worry about the PLL engine. So now let's concentrate on the crystal as well as the RC oscillator. So I'll come to the PLL later. I'll show you how you can generate higher frequency of clocks using PLL in the later videos where we do some exercises. Great. So these are the main clock sources. So to conclude this lecture, a microcontroller needs clock to operate. A clock actually comes from the clock source. There are three major different clock sources. You can use one among these. And the majorly used clock sources are crystal oscillator, the RC oscillator, and the PLL. The crystal oscillator always connected external to the microcontroller. The RC oscillator is internally, it is implemented inside the microcontroller, and the PLL is also a clock generating engine which is also internal to the MCU, and you can use one among these in order to drive the clock for the microcontroller. And in the next lecture we will know more about the clocking system of the microcontroller.